right? So if we have more tables, we can just serialize like this.
Wait.
So
We need
this,
some slash n's at some point as well.
yes, we do. So we can come up with something like this, but then the initial one is just this.
We are
Yeah.
forgetting the accumulator there, dude.
No, yes, I know, but the beginning is this,
Mm-hmm.
right? And then we're just gonna have the name and the thing and the entity, which happens to
Yeah,
have like the
between
role
the
ID and all of
percentage
that.
s's, we need the slash n as well to follow your example up there.
Yeah. So yeah, okay. So yeah, I think we're gonna need to do this anyway.
And we need to remember that's gonna the separation between tables will have two enters. We need to remember that for the serialization.
Yeah, for serializing back. Yeah, that's true. We can remove this enter here. Oh,
Which
this
enter you're
space.
talking about?
This space, I mean.
Yes, we can remove that. We can remove that.
Can we remove? No, here it's different. Oh no, actually here as well, I think. Yeah. Yeah, that's true. Otherwise, we're just gonna keep adding spaces to the thing. So something like this, or am
Yeah.
I going crazy?
No, no, I think you're right. The initial accumulator need. I would like for the initial accumulator to do. What do you want the initial accumulator to have? Like I was thinking about metadata, like how many tables the deserialization will have to deserialize, but I don't know if that matters at all.
How many? I think it's more useful to have on the ACC how many rows does this table has.
How many rows?
Yeah, because then we can just say, okay, like just pick this block here. Then let's write like this and see what it gives us, and then
Sure, sure.
we see the beauty. Okay, that should be it, I guess.
Yeah,
Let's
that's
run that.
the easy part.
Yes.
This is
So
serialization
actually,
of the schema. We need to read it back.
so let's not execute the schema and let's just write. So print, oopsie. Oh, I can just print, right? Print and line, and we're gonna receive the. We're gonna schema. Wait, it's schema serialize. Okay. Hmm. I think it just didn't. It's dumb. Okay, let's try to run. Dun, 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 dun. Okay, so it wrote this person,
Person.
role ID, 0,
Well, the table
age.
is empty, so it makes sense to be zero there.
Mm-hmm.
Age one. The one is the position, right? So this one is indicating that this is the second column.
Yeah,
Integer 32, and then we have a name, which is the first column, and it is a string with 10 spaces allocated to it.
I'm just worried about this here.
What's the problem with that?
We're gonna have to do a mask and know that there's a space. Okay, but that's on the trouble on how to deserialize this type, right? That's fine. Okay, now let's try to deserialize.
Theoretically speaking, we could use parser combinators to read that back.
We could, but I think it would be harder than just doing the dumb thing.
Well, I guess at least in the beginning, it's gonna be easier to just do the dumb way. But when we have like procedures and
Oh yes, that's true.
the other
Mhm.
stuff, maybe having like a more sounded parsing, it would be great.
Yeah. Okay, so so let's try to. We could just speak the SQL there as well. Yeah, I'm thinking about it.
Well, if we're
Yeah.
gonna go all the
Okay,
way
but
to
we
SQLite's
need to
way,
store. Yeah, but we need to store the like some extra metadata that is not part of this, right? Like
like,
row ID,
oh yeah, row ID is not in the
which
the
is
SQL,
not
yes.
much of a problem now that I think about it. But well, we already did most of it, so let's just keep going. That's a fallacy, but well, whatever. Deserialize. So to deserialize, we receive nothing, and then we just beat the schema. Okay.
Wait, why do we
Ooh.
receive nothing when deserializing? Don't we want
Oh,
to
a
save?
file, right?
Um, I
For
was
now, I
thinking
just
more
want to
about which
see.
schema you want to load, but we can start with a file.
Okay, okay. We can just make like one schema per file, and then that's done.
Yeah, but what if a file has multiple schemas?
Yeah, but then we just don't allow multiple schemas in the same file.
Sure.
Simple, simple, easy peasy. I don't
Sure.
see the problem.
Sure.
Okay, so now we just need to look. Let's try to
Ah,
write
actually, that
two at
brings
a time.
a very interesting question for you, that is the database specialist. How do you do versioning, temporal versioning on schemas?
Temporal versioning with schemas. You mean like how to version
Yeah,
modifications on the schema, right?
yeah. If I want to save the previous versions and whatever.
Uh, so if you do like you're saying, the concrete example would be I update this field here, I change the value of this field, right?
No, it's even more deep than that. I changed how a table, how
Okay,
many
how
the
table looks,
columns.
yes.
Sorry?
How table looks, how the
Yeah,
fields
the
that it
fields,
has.
etc. You change all of that,
Yeah,
but I want to save the older version.
you can have a snapshot.
Okay, okay.
So let's just write another thing here. We have person. Let's write this exact same thing, but with another name. So let's just do this and write, I don't know, we have 10, this number,
Well,
and
that is
it
the row
is,
ID, right?
yes.
Okay.
And let's write what here? Let's write ABC. I love ABC. Okay, so let's run this, see what it
So we
gives
have two
us.
tables in the schema.
Yes,
Cool.
there we go. So it's jumps one line.
Yeah, it jumps online. So we have two tables ready to save.
Mm-hmm. We can
That's awesome.
compress this later, by the way.
Oh, of course.
That would be nice. I was trying to use gzip on mine. Just
Like if
call
you
it
think
here.
about it, we could not only do XML or JSON or proto buffers and stuff, but we could theoretically do a CSV.
Yes, we could. Very, very true.
Oh, that's be cringing. Like some parts of the process we are doing it correctly, and some others we are
And
just
some
saying.
were not. Well, at least we're doing stuff, and we know the points of weaknesses that we
Yeah,
need
no,
to
we
go
know the
back and fix.
trade-offs. It's gonna be slower, so
Yes.
it's gonna be a
Ah,
lot
not
slower.
aiming for amazing speeds here anyway. Uh,
Now, if you want to dethrone Kafka and stuff like that, you're gonna have to
yeah,
have
of course we're
performance.
gonna dethrone Kafka. Yes, Levels with a
No, no, no.
database
I'm
with
not
no
saying that
trouble.
we are gonna do that. I'm saying that if you want to argue for that, you
Yes.
need to care about performance.
Yeah, no, that is different. Okay, so how do we read? I wanted to read just chunks. I don't want to read because the logic would be kind of weird, wouldn't it? Like if I had to read, let me put it like.
I don't think you can. Well, I don't remember having easy functions to run chunks. I remember having functions to read lines.
Yeah, because think of this, like I would have to read this line. Notice it's a table. I actually should write table, right? Now that I think about it, that makes a lot of
Oh
sense.
yeah, we're gonna have procedures at some point. That's true.
Yes.
So we
So
should
let's
write
just
that down.
do. Yeah, let's do table space, and that already improves the what? I literally. Oh, I added this.
Yeah, we need to remember also that at some point you're gonna have to do some sort of pattern matching because you're writing table every single time. So potentially you're gonna have like procedures being serialized as tables or whatever,
Yeah.
which is
Yeah.
not the best.
Okay, so let's just try to read the Ooga Booga way,
Okay, so you're gonna be doing like
line by
parsing
line.
right now, right?
Yeah.
Okay.
Okay, this is not.
We
I
need
think,
the to open a file and stuff like that. I always forget how to do that.
well, that's why we have here. So we don't have to
So you can
remember.
just copy paste.
Beautiful. That's how you write.
Oh yeah.
Okay, do you want to write? For now, I would say. No, no, okay. I would say like read the entire file and then go line by line, delete. But no, that's harder.
I think that's harder, yes.
Let's just
Well,
do the
actually, now
then.
that I think about it, you're gonna have to do that anyway, right? You're gonna have to do a fold with the try catch.
Man, I'm kind of thinking here. It seems much easier to just write like some metadata, like a key value, blah blah blah, on the metadata. You see? So for example, like table ABC role ID, and then we write and we dump SQL, and then with the SQL we just use the parser that we already have. You see
Yeah,
the?
but we're gonna have to do inverse parsing as well, dude. Like
Yeah,
we're gonna
we're
have to
gonna.
create a
Yes.
way to pick the already parsed thing and then undo that.
Undo it. Yes, which is not that much of a problem. Okay, depending on a procedure, I think it is a
I think
huge
it's the
problem.
same type of like it's gonna be the same amount of effort. It's just the other direction.
Yeah. Let's just keep with this. Just keep with this. But that's how bad decisions. Uh,
Are born?
not that just enters. When I say that's how bad decisions keep alive, keep being alive forever. Okay, so we're gonna loop over the contents, right?
Yeah.
So let's just do a loop here. I don't want to do a for loop, but
Yeah, I think we should do a fold in here.
I think the fold will be harder, man. I think I
Really?
prefer to do a for loop.
Okay, let me
Should
Google it.
I?
Read file line by line. OCaml.
Oh, we can do a while.
We were doing such a great. Oh, dude, you can put the while inside the try catch. So I guess
Hmm?
that works. Yeah,
Yeah, but
let me pick
then would
the. This is
then the
very
context. Oh, but wait.
non-immutability way of doing it, but you can do it like this. I'm gonna send the code in chat, so you can do it like this.
Copy without looking.
This is probably very cursed.
What you're
That's
saying, man?
okay.
Yeah, this is not the most beautiful thing I can see, but yeah.
It should be a fold, but okay.
So forgot to. Okay. Okay. So this just reads. We just put like this.
It doesn't seem to have
Oh.
um, a non-mutable way of doing it. So some people are using while, some
Oh.
people are using recursion, but
Oh,
it's
there
basically
is.
the
Yeah,
same.
but string list. Okay, that's I'm fine with that. Okay, so let's just do. It's kind of inefficient, but who cares?
Definitely not us.
I love the definitely not us. Okay, so we pick all the lines, and then we just need to. Oh, dude, wait,
Oh,
wait,
this guy's
wait.
using regex. That's smarter.
But wait a second. Like this is an empty line, right? So we can just split these lines. Like you can read until you get an empty line.
Yeah, you
So
can
let's just
split it
do
by
a.
that.
So let's just do. Let me see. This should be a collect. It should be something like a map. No, no, no. Sorry. This should be a fold with a collect inside.
A
Am I wrong
fold
here?
with a collect.
A collect, so you pick all the rows for this, and a fold to reduce the things for the table.
What is a collect doing again? Can you repeat that?
The collect would be picking all of these attributes for the which is also a reduce, right? It's just a specific reduce because we
Well,
need to read like these many lines until we hit a new line.
yeah, but the problem is
Like
that
line.
we don't know how to read like read the entire file by lines. That's the problem.
Let's just print this so we can see what's happening here. Oh, but I need to. Oh, kill me. Uh,
Okay, so you're using the ether. I think that kind of works.
I need this.
Okay, so let me see how we can read um, an entire file.
We have a one problem here because we're not writing to a file on this. Yeah, we would need to write to a file first. So let's just write to temp again.
Wait,
Uh,
what do you want to read and why?
this to test this. This is actually assuming that it's opening from a file name, right?
Yeah.
We're not passing a file name.
Oh
Okay,
yeah,
so
no,
we
not
just
in the
need
main
to pass.
function. Yeah.
Yeah, so we need to write first. So that's kind of cringe because we need to do.
Another solution from Jane Street. Okay, so there is a library called core, and in there you can read the entirety of the file, and you can read the lines. So I think that's gonna be pretty useful for what we are doing.
What is it?
Core. Oh,
I think I saw it. STD core, right? I
yeah,
think I saw it.
I think that's open core. Apparently, it's how you open the
Yeah, but
namespace or
it's
the module.
what's the name of the library? Open core.
Yeah, open space. No, not open core. Let me find.
Oh,
So
open literally core,
yeah,
right?
yeah,
Like
yeah, yeah, yeah. Open space core with capital C. Module Jane Street. Okay, yeah. So core is the name.
but I don't think it will be that impossible. Let me see here. Mm, CMS, that's our schema. Okay, so we pick this and then we just write the chunk, the whole thing. Oh wait, but I cannot print then. So out. Let's do a fun text. How do we write again? Do we need to call? Oh, we just.
Oh, this is being done in another place. We can copy paste from there. I don't remember how we write. For some random reason, everything IO related with OCaml for me, I immediately forget immediately after we finish.
Here, output string. So we pass the channel and the string. X. We're gonna write it and just propagate
Oh,
X.
you can do. Oh no, you want to write it but then propagate. That's why you need to do a fun there. Okay.
Yeah. And then this diesel come on. Are you crazy? Ah, dude. This is okay. So this just oh, this is not inferring yet. So we just pick that and then print end line. Let's see. Error. This expression has type unit, but the expression was expected type string. So this is type unit? What?
The serialize has type unit, yeah.
Oh, because it's an iter. Oh, okay. So we don't need to print just this. So it was right.
Wow, that
Exact.
compiled.
No such
Uh,
file or directory because that is
that file doesn't exist.
yes, which is true. The file doesn't exist.
So it's probably a mode or whatever. So let
No,
me.
yeah, it is like I'm piping this. thing to the deserialize, but it's not the case, right? It is, it shouldn't pass this, nor this. Yeah, this was dumb. I passed the name of the file, which is this.
Oh, okay, now I see it, yes. Yeah, I was not following
Okay.
that, but it makes sense.
Okay.
And it did
So
a bunch of nothing apparently.
yes, it didn't print anything.
Oh no no, but you're not printing it. So probably it
I am
deserialized. Are you printing it? Where?
end line here.
What
At
is the
least
list.iter does again?
it loops over and spits nothing. So it just causes an effect, which is
So
printed end line. Don't even need this.
so it's just reading the contents of the file and then printing it.
Well, it should, but it's not.
Okay, can you print the file name in like somewhere? I already forgot how to do that as well.
Like this and then semicolon.
Yeah. Oh, maybe we're having. Oh no, it isn't here. It is there. Okay, can you cat? Yes, that's exactly what I wanted.
Yeah, the file is right.
Um, do you think we could open utop and do the read file and see if it works?
We can do just do this. Ah, dude, what is wrong with me? So expression was expected to have the type string list. What? Did I? Oh man, this is REPL is
What is the one? STBL, the Lisp one? The same feeling. Same goddamn feeling. But anyway, I want to add,
FBCL, yes.
but I'm not understanding why you are copying this part because I think that what is not working is the iter.
Yeah, but I want to see if it's actually reading the this file there. But
Oh, you
the
made the read file function. Maybe that's wrong. Okay.
so let's pass the TMP as schema.cms. Oh, this. And there it is. So it has everything just fine.
Yeah, but the iter is wrong.
Yeah. Well, let's try to do what they're doing there. So list iter print end line with this. It prints. So
Oh
why
fuck.
doesn't it print on the thing?
Uh, can you double check if you saved all the files?
I did.
Uh, uh, serialize schema.
Unless. Okay, this is the junk from the parser.
Which I don't understand why we have this.
It's because I added a flag there with
Ah, that's fine.
to have more verbal stuff. And we're calling parse here. Uh, yeah, this is strange. Maybe it's my terminal, man. Let me see here.
What is output string
eShell.
again?
Wait, let's trust eShell for a second.
Eh,
If eShell shows, that would be amazing.
no.
It doesn't. So it is
Yeah,
not
it is a
important.
problem in the code for sure. Can you go back? So, what is output string doing there? What is that? Is that a function?
Yeah, so this is just writing. So I know this is working because otherwise we wouldn't be able to cat on the
Yeah.
file. And this serialize does just receives the file name and spits and prints. This is the thing that should actually print with this iter.
Are you missing any semicolons?
I am,
Why didn't
but
complain about that?
I don't know.
No, it still didn't
But
work.
yeah, but I mean it's the end expression, so I don't think that's necessary.
Um, um,
Oh, wait. Could it be this partial? Oh, man.
oh my god, we are doing a reverse on the list of lines. Yeah, we definitely do not care about performance.
I I don't think we should. Yes.
Yeah, it's still
So
not working.
let's.
I don't understand. I totally don't understand.
I don't as well. So have to go have dinner now, because it's 9. Can you pick this up?
Yeah, just commit.
Whip serializing schema. We can finish this very quickly, I think. We just need to cope with this
I need to
stupidity.
think what's gonna be the strategy of serializing, deserializing, like reading this back because
Yeah,
um,
the problem is reading and knowing which chunk it is. But you can, by the way, you can check with Nathan while I'm gone. See if the using the Jane Street PPX thing is easier.
yeah, there's a
I,
chance.
I don't know. There's nothing there, so sure, but well, could be. So
Yeah,
I'll be
there's a
back in like
chance.
a minute or so. Just a sec.
Sure. Okay, so let's open a terminal. Right. So let's open Camelot. Let's do a git pull origin master. Cool. Let's do nix develop. Awesome. And then we can do open init. Cancel all this stuff and just do eval dollar open. Okay, and then we can do the source and then do build. It does build, do exec, CamelotDB. And it isn't working here as well, the print. That's expected, I guess. So now, I need to do, actually, let me close these Emacs and let me open from Nix develop. Okay, cool. So let's go to AST. Okay. Mhm. Okay, so after having, so let's put um, let lines. Let's say that this is equal to read file name in unused variable. That's okay. Then then we need to parse this stuff. We need to parse this stuff. Hmm. So I believe we can do that using a fold. I get to remove the example from here. Okay, so let's actually do a cat tmp schema. Okay, so this is the thing that we want to be able to parse. Oops. Let's save this. And I can't copy for some reason. Yes. Okay, so this is an example of a schema. Um, okay, actually, let's just return lines in here. And let's say that read file name, let line is equal to this in lines. Okay, so let's say parse schema. You're gonna receive a string list, I believe, which will be the lines, and you're gonna return schema. So I believe this is gonna be T. Okay. So the first thing that you need to do, we're gonna do a map, I believe. A map, input line, that, yep. So we need to go to list operations OCaml. Let me put this on the screen. Okay. Now we need to do some sort of a split. Transform a list of pairs into a pair of lists. Okay, so they're calling unzip split. That's okay. This is the only one that we have. Do you have any sort of group? No. Awesome. Partition. So for all, checks if all elements in the list satisfy the predicate f. That's not what we want. We don't have grouping. We don't have grouping. That's really, really sad. So let's see. I really don't want to do this by myself. It would be really nice if the library is already doing that. List searching, list scanning, association lists. Returns the value associated with the key A in the list of pairs L. We don't have the pairs, we have a list of lists. No, we have a list of strings. That's what we have. And I want to split them. Sort and sequence. Sequence module OCaml. Maybe sequence has consuming for die for all exists fine equal compare unfold repeat. This sounds a little bit more promising. Group. Ooh, so this guy has it. Ah, okay, so that means that seek lines um, let seek lines equal to list to sec okay, now we need to do groups equal to sec dot group. Group is a thing that receives, provided the function Q defines inequality of elements, is the sequence of maximum runs of adjacent duplicate elements on the sequence, provided the function. I don't know if this is exactly what I wanted. Every element of group is a non-empty sequence of equal elements. The concatenation is equal to XS. Consuming group and the consuming sequence that it contains can cause XB to consume more than once. Therefore, XS must be consistent. Splitting the sequence. It is an alias for unzip. Where is ah, partition? Returns a pair of subsequent elements that satisfy P and the subsequence of elements that not satisfy P. That's disappointing. I want Haskell's group. Scan. Sequence says scan. Take a while could work, but take while could work. Yeah, but we need. That's not what we want. That's not what we want. Sorted merge. Partition map. Turns a pair. Well, I mean, we could do partition, right? We could do partition and then fold on it. That works. There's a pair of elements that satisfy and the subsequent elements that does not satisfy. Partition P is equivalent to filter. Oh, this is not doing only a split. This is doing a. That's also not what I want. Oh boy. Oh boy. Oh boy. Append transpose. I think I'm gonna have to use group anyway then, because I don't have the other functions. Cycle, repeat, unfold, compare, fold left, feature 2 exists for all, iter, yeah.
I am back.
Well, I spent this entire time searching the functions that I need.
Okay, you're not sharing, by the way.
Oh, I'm not sharing on Discord. Okay, so my first instinct was to use the list, right? And then I was thinking
Uh,
about using the fold with the split. But then I discovered this fold, this split is actually an unzip. And then I said, okay, maybe
oh,
the sequence has one, and the sequence doesn't. But at least it is honest with you. Like it says exactly what it is.
it is for unzip.
Yeah.
Why? Just why?
So after reading all the functions, I think we're going to have to do some sort of very intricate trick to using the function group. So,
Yes, like a group. It sounds like a group by,
but it's not.
but
Well,
it's
it is a
not.
group by actually. It is.
Yeah, not really, right? Because the group by entails that you would want all the fields with the same, but you actually want to just like pick everything before like separating by just a thing, right? So
Yeah,
let me
that's what I
think in
wanted.
abstract what
I,
would be the function.
I
Let me see
think
if I find it here.
I think that in Haskell it would be something like he also has some sort of partition function, but the partition is not this Haskell's partition, which means that it's not doing like, oh, pick the elements until this predicate is true, and then from the point it is not, just provide me the rest of the list in the second member of the tuple. This is what partition in Haskell does, as far as I remember. This is not what the partition does in here. The partition does a filter and a negation of that filter. So it completely breaks the order and completely breaks the fold that I was thinking about on doing, which is very sad. Oh no, Haskell's partition is also that. Okay, so I don't remember which function I would use in Haskell, because apparently this is also the thing. But there is a function in here that is doing the split at whatever.
Oh, I know how to do it.
Tell me.
We're gonna need to fold.
Yes, that I was thinking
Uh,
about that.
okay, so let's try something like. Let me think. Okay, I have the code in my brain.
Okay,
So can I go to
let's go to
Emacs?
Emacs.
Okay, so start typing. I will dictate.
Yeah,
So you want to make a recursive function
a recursive function.
uh, that sees if the. Oh, sorry. Let's define. It will be a fold. So let's do a fold. So a folder.
A fold.
So, yes. So the fold function picks one element, like an X, and then it picks the accumulator, and then we see if the accumulator is an empty list. And in that case, we just split a list of list with the element of
We
the
just split
X.
what?
We split a list of lists with X inside. Otherwise, we split the head and tail, and then we check if the next position of the list. Oh, if the head is equals to the separator, which is the empty thingy, then we. Okay, in that case, we just. Let me think. Okay, this is weird because we need to do an if, I think. If the next element is
Wait,
so
before we do that,
okay.
I think it's easier for you. I have an example here because I
Mhm.
executed the code in my system and did the cat. So can you tell me your algorithm using these examples?
It would be something like this. You basically pick the element, but line by line. So
Yes.
that each list, eight string, right? And
Yes.
then you want to split into a list of lists of strings, correct?
You want to split to a list of lists of strings.
No, sorry, lists of strings. So
Lists of string.
yeah, because that would be a list containing table, age, name, and then another list containing table, you see?
A list of lists. Don't you want something like uh, and this, and then, oops, here, and then, don't we want something like this along these lines?
Let me see. Yes, exactly that. Oh, not really. Yes, each one of these is a string. Yes, exactly this.
Yeah.
That's what I was trying to think. Yeah.
Yeah, so what I was thinking about this is that we what I wanted, right? What I wanted was, okay, first pick the initial thing, the initial list, and split by empty lines using the separator. That was my first idea.
Hmm.
Because then we would have a list containing these guys. That actually that would already be enough. Do you agree? That if we split using the empty line, the result of that grouping would be having a list with these three and then a list with these three. Does that make sense to you?
Yeah, that's exactly what I thought, but I'm trying to think of a recursion in this case.
Um, let's do that function actually. So let's call it let split groups. You're gonna pass to me a separator, which in this case is gonna be a string. You're gonna pass me lines, which is gonna be a string list. And what we want you to return for us is actually uh, string list list, right? Does that make is this the type signature that we want?
Apparently, yes.
Okay. So I think in order to do the recursion, we're gonna have to make an internal function here that I'm gonna call it inner. So this is
Yes.
gonna be the function that we're gonna use in the
Oh,
fold.
dude, I get it. I get it. It's an existential that we want.
It's what?
It's an existential case
What
that
is
we
that?
want. So if okay, I see I have the algorithm in my head. I have it on my head. Something like this. You split. Okay, right. What does it say? Like this inner will receive the x and the accumulator.
What is x?
X is just a string, and accumulator is a list, an empty list.
A list of what?
In this case, it should be actually a list of strings. So string list. Yes.
Okay.
Okay. So then match ACC
Match ACC.
with yes. It doesn't even need to be recursive, I think. So
Wow.
empty.
Empty.
No, empty list.
Oh, is this empty list in a comma?
Yeah.
Okay.
This leads to one list with another list inside with the X. Yeah. And then we split the head and tail.
We split the head and tail of what?
The next case,
Um,
split the
what
head,
is how is the
X,
cons again? It is
uh,
this.
column, yes, X and XS. And then you do if, uh, uh, new line because there's more. If a list exists, I think there is one thing like this.
If list exists,
Yeah,
so
contains exist. I think it
list
exists.
dot con
I think it exists. F sharp is exists.
exists,
Yes, it is. Exists too. Okay. Um,
and
and then
so
we
what is this
see with the
expecting again?
separator a
It is a
function.
predicate and a list.
Yes.
So the
So the
predicate would be
predicate
what?
is equal to empty.
Equal to empty is what? How is equal in OCaml?
Just to wrap in a parentheses and just one. Just one. Uh, yes, on the head and then in this case you just append the X as a list. So open list, close. Yes, and then cons with the ACC.
Else,
Uh, yes. Else, okay, it is a lane cons head. Oh, okay, this makes sense, dude. No, that's okay. Separator. Yeah, Elaine, which is in our case X, right?
oh, sorry.
Column for cons with the head.
The
Oh
head of what?
wait, you shadowed it. Oh man, okay, that's why I said Elaine. You shadowed it. Like the X on the inner should be rename the X
Oh yeah,
to I don't know
shadow. LM.
value whatever. Yes.
LM.
Yeah. Okay. Elaine's fine. So it should be Elaine cons with the head, which is X. Yeah. X as well there.
Where?
Yes, on the den.
LM here?
Yes. And then there, yes, but then you need to wrap in a parentheses again.
Which one? This part?
Yes. And then you wrap again into another cons with the tail access.
I don't know if I
Do
understand what is happening here.
and then let's see if it will work. I don't know, man. Let's
Wait,
see.
can you try to explain me the logic?
Okay, so do the fold first. I think it will be easier.
So it's gonna
So new line,
be in
out of this function, yeah, in and then
list
list fold.
fold. This is not
Uh,
the inner, right? Because the inner,
yeah,
what is the type of this? Is wait, what?
this picks a function, right, which is our inner. Oh,
Inner,
it is inner. That's true. Yeah, and then the
and then the accumulator, which is gonna
yeah.
be an empty list, and then
No, no, it
lines.
comes after. It comes after. So the lines is before the yes. Stupid.
Unbound
Okay,
value.
why is it complaining? Oh, do you need to pass fold left or fold right? No, this is
Okay, so this
exists,
picks
doesn't it?
a string list. Yeah, we are missing a thing in the inner function, that's for sure.
Wait, the
Yo.
inner should take a string
Oh no no no,
and
you're right, you're
yeah,
right, you're right.
and split
Let's just
something.
type this down in order to I don't be confused.
String
List
list
list.
list
Okay, so we pick that. Then we pick the string list, which is gonna be the lines.
lines, yes, and
And then
then
we
the
pick the
accumulator,
accumulator.
which is a weak list. Okay,
And then this needs to give us what?
a string list list. That's fine. Why is it?
Unbound value.
What the heck, dude?
Weird.
Very
Okay,
weird.
anyway, I want to understand this algorithm first.
Okay,
So if the
so
accumulator is empty, you just put the
you just
first
yeah.
element. So you're
So
gonna put the table, right? In this particular case, you're gonna put this line there.
yes,
Okay.
and then if it is not empty,
Yes.
then you
Then
pick
you
the head and the
check
tail.
if it is if
Yeah,
this
but
thing
wait. What is the head and what is the tail? Explain to me
this is
on
gonna
the
be
second.
table table this and this is gonna
Mhm.
be empty.
Uh, this is going to be empty on the second. Let me think here. Um, no, that's wrong, isn't it? Let's see.
No, in the
On this
second iteration, I
function.
mean.
No, okay, that's true. Okay. Mm-hmm.
Okay, so this is gonna be table ABC 1134, and this is gonna be empty. Okay.
Yeah. Mm-hmm.
Then you check if this is equal to x, which is not gonna be.
Yeah.
So it's
If
gonna go to
if
this.
the list is on the list X is equals to the separator, right? So if the element you picked on the last thing of this table, remember cons always adds to the beginning.
Yes.
So you're basically checking, okay, this thing on the beginning is actually uh the value that I'm looking for is to separate. So if it is, which is not the case for table, then it will go on the else in that case.
Yeah.
So
So
it
we
would
are
be
comparing table ABC 134 with empty thing, right? Empty line.
mhm,
Okay.
yeah.
Then that's not gonna be true, so it's gonna go to the else. The
So it's gonna
else,
be age one.
yes, it's gonna be age one, and then column with the table.
Mm-hmm.
Um,
So this is bad because it's gonna go to the
it's
beginning.
going
Yeah,
reverse.
but we can just reverse back later. It's very
Um,
bad, but yeah.
and then you just pick the rest of it.
Yes. Yeah.
Okay, in the
Mm-hmm.
second iteration, the accumulator will not be empty again, so you're gonna do this again, but this time this x has two things in it.
Mm-hmm.
Let's assume that this is gonna work. Let's go
And
to
then
the
it's
case that
gonna
it
go
is
on
a
the
separator.
else again, and it's gonna append, and then it's gonna fill the third.
Yeah, and then uh, the fourth case, which is the one that's this if is gonna be true, right?
Mm-hmm. Then it
Oh
just
wait, this is
picks
not
the
x, right? This is ln.
no, it is the
Because you're comparing a list with an empty thing.
no, but wait, the head is not empty.
No, no, no. But do you agree that the head in this particular case is it is these three things, this list?
You are always comparing with the last one,
You are always comparing with the last one. The last
or
one
natural
what?
boost.
X is what? A list. Do you agree?
So let's see. The first passage it will complete those 3 lines. I think we're met there.
Yes.
Then
No, no,
it
no,
will
wait,
say,
wait,
okay,
wait, wait. Before that, do you agree that if you compare this to X, you're actually comparing a string list with a string?
X is not a string. X is a list of strings.
Wait, wait,
The,
wait, wait,
aren't we
wait.
appending to the head? Like it's
You're
falling on the
checking
else.
if exists. You're checking if exists.
Yeah, we're checking if
Checking
the
if exists.
separator is on this X, and that
So you
happens
are
to
expecting that at some point it will be inside, right?
yes.
Oh, dude, that's why I'm confused. Okay, okay. So you're actually not using the separator as a marker to divide. You are including
No,
it.
I'm including, and then
Ah,
when I see,
oh, my mind is melted. Okay, so in the case that it is, which will happen anyway,
Mhm.
eventually it will happen, that means that you're gonna just put.
Yeah, just gonna insert in a empty group, right? The separator, and then in the end we just filter the list with like deleting those.
You're gonna put the separator.
By the way, you can run this on the interpreter.
Yeah, just a sec. Okay,
It's
let
gonna
me
be some,
let
it's gonna
me
be something like this. Add to the code line. Oh wait,
go.
line 16 up.
16 up. 16 up is here.
Add a new empty list. Oh, sorry, not empty. A new list with an empty string inside. Yes, it will do this, and
Yeah.
in the end as well.
Oh, in the end as well.
Yeah.
Yeah, so before we go on, I want to propose a change in here. So let me call this let split groups 2, and it's going to work in the following manner, right? So,
Let me see if this works. I was writing here.
okay, check that. This match is going to be the same. Oh, I think I know. Wait, I think I know why you did it that way. Because you need a way to identify that you need to start a new group.
I I think I'm thinking here. I think it will add. Let me test this actually. What happens if I? Oh, it works, dude. Yeah, but there's just one thing that I think will happen is sometimes it will not split the zero. Uh,
What do you mean?
oh, okay. I use numbers instead because it's easier, which is an empty thing. That's why. Yeah, I did like 1, 2, 3, and then 0, and then 41, 2, 0, and then it split fine. So there's a group of 0 that we can filter, and a group that included the 0, which is fine. We can just like filter, but this is kind of cursed. This is not what I. It works, but it's just junky.
How do you pick the first of a list in OCaml?
This. Oh, just
HD?
I think it's list.hd.
Um, then what you actually want to do
It's unsafe,
is
by the way,
what?
which is unsafe.
No, it isn't safe. I'm just thinking out loud here. So in that case, you want to do first um, cons acc. Is that it?
Let me see what you're doing. If the element is equal to the separator, then you just append an empty list with the accumulator.
Yeah.
Otherwise, we just bind the first element of the thing, which is a list, and then you just append, okay, you cons with the element you are currently looking at. Yeah, that looks better actually.
Okay, so let's do a test drive. So the first case element will be table ABC134. It's
Uh,
not gonna be equal to empty string. So we're gonna add the future home of this group, let's say.
yeah,
Then in the case that's not equal, oh, actually, sorry, this case is not the first case. This is the first case.
yeah.
So table ABC134 is not equal to separator. Okay, so else we're gonna pick the head of the accumulator.
Lemos,
What?
he froze.
Can you see my cursor changing?
Yeah, it's back. You
Okay,
just
sorry,
froze for a second.
sorry. So in the case that table ABC134 is not equal to the separator, we're gonna pick the head of the accumulator, which is unsafe,
Yeah, but it's
right?
it's fine. I don't think it will, unless we have an empty
So
schema.
this
I don't
this
think
needs
this
to
will
be
be a
the
problem.
this needs to be the first accumulator. So we pick the first of the accumulator, which is this case is gonna be an empty string, the first. Then we put the element inside there,
Mm-hmm.
and then we just append the rest of the accumulator. We are basically, oh no, we can't do a head. We need to do a pop, right? We need
Yeah,
to
you need
actually
to move
mutate.
it out of there. Yeah.
So
So
do we
why
do
don't
we
you
have?
dismember?
That's actually better. So let's pick the first and the
Okay.
rest.
Yeah.
Let's call this tail. That's fine. And then we can just do tail here. Yeah. So in this particular case, the tail will be an empty list. Uh, ooh. Oh, this is new. Okay, this is new actually. And this is empty list. Then we append the elements to the empty list, which in this case is going to be table ABC, blah blah blah, and the
Yeah.
remaining empty
With,
list. In the next iteration, is going to do the same.
let's suppose it hit the empty. So it would have some data, and then it would do. Okay, this thing is actually the separator. So you
Yes.
just
So you add the future
ignore
new
it
home for the next group.
and ignore the thing, and that's fine. It iterates again. Then it will pick the first, which
Which
is
in
an
this
empty
case is
list.
going to be an empty list, yes.
Okay, yeah, that's fair. Yeah.
I'm not saying your version is bad, it's just because
No,
I'm
no, it's
dumb.
it is. It's more easy to read, at least.
Yeah, that's my problem. Okay.
Just run on the OCaml REPL, see if it works.
Um, I don't know if that's going to work, but let's try it. Dune Utop.
Oh, just to run OCaml. Just OCaml. No, just OCaml. Copy and paste there.
I don't trust it's going to work, but okay.
Well, let's try.
Uh,
Semicolon, semicolon. Control, yeah. Semicolon, semicolon.
syntax error. So line
Don't
8,
delete. Don't delete. Just paste. I learned the shit.
just
Just paste.
paste.
Control, yes. Semicolon, semicolon.
Here is an
Unbound
example of a
value
case that
list
is not
fold.
matched.
Try list fold left
That
or
doesn't make
fold
sense to
right
me, but okay.
or fold right. I don't know.
Do we have fold in here?
No, there's no fold.
Oh, there's
What
no
the?
fold. That's why. Okay.
Okay, just pipe this.
It is
Fold
fold
right.
right, what we want.
Yeah,
Yes, it
fold
is
right.
fold right.
Whatever.
Okay.
Okay, let's see. Yeah.
Here's an
Okay.
example of a
So
case that is not matched. Here's the case of an example.
yeah, that's just like
Okay.
the pattern matching you did on the let.
Which one?
The
Oh,
let
the let first and
the
tail. Yeah,
dismembering.
okay.
Yeah.
Okay, so split groups, true. Then let's, I don't have,
Yes.
one, true,
Is your life
three,
miserable?
empty,
Mm-hmm.
4, 5,
Empty.
empty, and 7 and 6.
Put empty on the end as well.
like
Yes,
that.
because I think it is like this. Okay. Semicolon, semicolon.
This expression is type A list, but an expression was expected to have
Huh?
what is the thing? Oh, the separator.
Oh, okay.
Ah,
You need to copy.
awesome.
Oh, and no, 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 don't do this. Copy just the name because you cannot move the cursor,
Yeah,
right?
I figured.
Yes, curse.
Oops. Okay, copy that.
The expression has type.
What?
What the?
Am I
Oh,
using wrong
oh,
syntax?
you're using a tuple. That's a semicolon instead.
Eh.
Okay. The type, man. And it works.
Ah!
The only problem is that's what I thought. The only problem is the last one.
Yeah, but then we can just. Oh, that's
We can
expensive.
check the size. Can we? No, we
That's
can't.
very
No.
expensive, dude, to drop the last one. Ah,
Yeah. Well, we
that's
can
very
check the
expensive.
size and see if it's the last one. We just don't add.
We can do a filter.
Yeah, but the filter is also bad. Uh,
Well, I don't think
yeah,
we really have a choice in this case. So filter. How we do different in OCaml?
uh, angle brackets like in the opposite direction, like sickle.
Like this?
Mm-hmm. Yeah, but you need to wrap in parentheses to be a function, like infix.
Okay. Oh man, this function was not the best one that I. uh,
Oh, it's easy to read.
okay.
The only problem
Okay.
is the exhaustive case.
Yeah, but that's we can do it like this. Fail with something went terribly wrong. And then we can just do first tail, and then we can just say that this is equal to this. Okay.
Uh,
Ah,
Beautiful.
this was hard.
Yes, this
Okay.
was harder than I thought it would be. Okay, so
Ah,
now that we can split, finally.
okay, so let's actually just call it.
Hmm.
Um, okay, so there. I don't know the indentation is wrong, but anyway.
No, that's fine.
So groups, let groups equal to split, and I use Haskell convention again. There. Uh, split groups. The separator will be this, and these are the lines in. Okay. Um, oh, this is missing this. That's why. Okay. Okay. Now we have the groups. What we need to do with them? We
So
need.
once we have them, we just need to read one by one and recompose the types. So if we know it's a table, oh, this is gonna be hard.
Well,
We
hard
need
is not
to.
necessarily the word, but it's gonna be very inconvenient
It's
because.
going to be a fold again. Yes, it will. It will be a fold again, in which we do a loop inside as well. So it's like two folds, one for the outer, like
And
for
one
all
for
the
the
groups,
inner.
and one from the inner groups. Yes.
Okay, so let's
Uh,
make an inner here. This guy will receive. This is gonna be the folding, the inner folding function. So we're gonna map this fold in the outer. I think you got it, right?
yes.
Okay, so we need the element. The element we're gonna put, I don't know, a line,
Hmm.
right? And then we're gonna have the accumulator, which is basically gonna be, I don't know yet, but it's okay. Then the if list dot contains. How do I check that?
Exists.
Exists. Um, and then this is gonna be equal to equal. Um, no, I don't want I don't want equal. I want a contains. Like if this string contains this substring, you know what I mean?
Well,
Because
that
I want to
if the
say table
string,
here.
wait, if the string or the, you want the string inside the list, right?
Yeah, I want
So it
like the
is, it
first.
still exists, but you need to do a lambda that picks the string and then do a string comparison,
No, but
like
I
a
don't want
sub.
a string comparison. I want to
Oh,
see if this string here,
has table.
table, whatever,
Yeah.
person 134. I want to see if this string contains table.
Yes, that's what I'm saying. Fun, pick the thing, and then you
Fun,
do a string, substring inside.
substring,
Yes, it's a type string. Dot. Yes.
sub.
No. There is exists, but it changes a char. Oh man, that's terrible.
Starts
Starts
with
with
is almost what we want. Compare,
compare,
concat,
concat, contains. That.
contains. Okay,
But wait, it
if
receives in char.
it receives.
Oh man, that's stupid.
Okay, so it's a very not best contains.
Yes.
So contains from
The
escaped
heck?
fold right gets for
Man, are you
days
serious?
iter length make no
How
no
bad could this be?
also no no trim no unsafe. It doesn't have contains a substring.
Dude, this is so stupid. The contains a char. Like, what the heck, dude?
So let's see if LSP is trolling. So let's search for sub
Oh man, the substring is just by the size.
by
Like,
the
it is
indexes.
extracting. Well, you know what are the indexes, right? You know that the amount of words
It's
that
getting
table need to
cursed
have.
each time. It's
But
getting
it
even more
is.
cursed.
Yes, it is very cursed. But that's a way, at least.
Okay, so sub, then we put s,
Man, this is
and
so
then we put
stupid.
0 with 1, 2, 3, 4, 4. It is inclusive or
Yeah,
not?
I don't know. We're gonna discover.
Boss length. Oh, it's the length. It's not the indexes. Yeah, so it is 5 then. 5.
So, okay,
If this is
starting.
equal to this,
You need to pass, I think, the equals as a, yeah, parentheses. Oh wait, you want to share? Okay, never mind. If the substring is the same, but you still need to do a list. Yes.
I know. Okay.
Yeah.
No,
Press the
that's
list.
not true. Because this is a single individual line. This is the inner loop. So this is just the string sub.
Oh yeah, that's true. The inner loop doesn't care about.
This is still phenomenally bad, but that's okay. Line, line. Okay. This expression has type string. This is not a function. It cannot be applied. Am I missing a
Then,
thing? One, two,
then
three.
you forgot the
One, two,
then.
three. Oh, the then. Okay, if this is a then, that means that we
It
have the
is
name of the
indeed a
table
header
and we need
table.
the row ID.
Yeah.
Don't we have split by spaces, dude? Like,
Yes. If you
ah,
don't, I'm quitting. I'm ending it all right now.
split on char.
Man, I was thinking it's going to be. Yeah, I will not say it's better to do in C, but
Yeah, I
oh,
think you
there
learned
is
your
a split
lesson
on
to not
char.
say that.
It is split on char. Yes.
So is this list of all possible empty substrings of S are delimited by the character sep. Oh, this is perfect, actually.
Yes.
So
At
we have
least this one.
fields equal to string on split on char. The
Yeah, but
separator will be this, and
there's
then
one
the line will
problem.
be there. And then we can just
Separator
say
is space.
separator is a space, sorry. And probably I'm using
Yes,
is
it's
this
yes.
Split on char. Am I missing a thing? So it is only two things. Oh, there's no this. It is this.
Mm-hmm.
Then we can just pick the first one.
Just
Right.
fix something.
What?
Go up, all up on this file.
I'll open this file.
On the type, on the string, there. Go down. Go down. There. On the string, remove the space there, put like a brackets or parentheses, whatever.
Remove
Line
what?
30. 30 down.
30 down.
Go to the string. Yes, there. Put a parenthesis instead of yes.
That was a very good move. Congrats.
Okay.
I would totally forgot about that.
I loaded the code in my memory to do this.
Okay, now, now.
If the first one is a table, so fields, head, we can't do this if this is not a array. But
So
we can
it's a
convert to array.
list.
We can
HD
convert to an array,
fields.
dude.
We can, but I don't know if we should. Right.
Yeah, I think it will be easier. Like it's already cursed anyway. It's better to just access with the index. Yeah, dude. Like I don't see it should always be like this. If it's not, it's the schema is corrupted. So it's fine.
Let's grab an example to keep on the eye on, and let's do the conversion then. Ah, why it always it ends up like this? We start doing it properly, and then something happens, we stop doing it
Oh man,
properly.
like I blame the library. Like the standard library. I blame it for sure.
Uh,
Type to array of string.
there's no
No,
there's no
array of string. Array of string.
oh array of
Of
list
list. Yes,
of
of
list.
list.
Okay.
There. Now you can do instead of head, you can just do dot zero. Dot blah blah blah, dot before the yes.
What's the type
What?
of this? Array, string array, cool. So are you sure?
Well,
Accessing arrays.
unless F sharp is different, it is not like what the heck? It is with parentheses?
Ah, awesome.
What? This is very strange. I assume okay, in F sharp it's with like squared brackets.
Okay, do
Okay.
we have pop?
So
Now that this is an array, can we remove the head?
I think we
Ah,
can. Yeah, but
pop.
why would we need that?
Because we don't want the head anymore. I want to fold now.
Why would you fold, dude?
Because I'm gonna fold in to create the rows, the columns, right? Like I'm gonna create a map here. Do you agree? I'm gonna create a map that has this name.
Wait, you have a line, and then you're gonna basically do
Yeah.
position 1 is the name of the map, and position 2 is the row ID.
No,
And
no,
then
no.
you
Wait,
fold
wait. No,
everything
no.
inside.
It is the opposite. Now that we know that this is a table, we can start using the types that we created up here, right?
Yes.
So for instance, a logical map is a map of using a string. This string is this name, right?
That string is this name. Yes. No, that's actually entity, right? So it is the. Can you go to entity?
Entity here.
Yeah, that is actually a table. Yes, that's actually a table.
Oh yeah,
So you
that's
don't
true.
even. Yeah.
That's true. Wait, what is this string in the logical map then?
This is the name of the table of the entity. So the table person, like it is that, but then you add an entity inside.
No, 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 that's true, that's
So
true. But do you agree then that this ABC that we can just put person, just for the sake of
yeah.
being better named? So this person will be a key in this map here, or no?
Yes.
Okay,
Yes, that's right.
yeah, so that means that you can start instantiating proper ADTs instead of depending on strings.
Yes, that's true. But
Okay, then we're gonna put this number here, 134, we're
it
gonna
should
put
be the
that in the
ACC.
metadata, right?
Yes.
Okay. What is this string in the entity again? Do you remember?
The name of the field,
The name
like
of
a
the
name,
field.
age,
Oh yes, yes, yes,
email.
yes, 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 yes. So now we need to make an empty map. for the logical map of the schema.
Actually, that should be the accumulator already.
Yes, yes, exactly. Do we have fold in this thing? Yes.
But I still don't see the fold, man. I see the fold
Let me
attribute.
explain. Let me explain. So we're gonna do a fold in which the initial accumulator will be the 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 map with already this key.
No,
And
but wait a second. Like, what is the array you have there? It is always just three things.
it
It
is
is
always three
table,
things.
person, one, two, three. One, three,
Oh,
four.
you're
This is-
right. This is the inner fold. So we
Yes,
only have
we're
access to these
thinking of
three
the
elements.
outside. What you're doing right now is not parsing. It's parsing only
Okay,
the.
so actually what, not return, what we actually need
We,
to return is actually a tuple, right? We need to return the fields one in order to have the name of the table, and we also need the row ID, which is going to be fields two.
this is somewhat weird because we are parsing. You forgot the dot. We are parsing something that shouldn't be in there because we just want to. Okay, never mind. We just need to parse one. Okay, but this is still weird, man, because we will need to call the another thing to serialize how we want the attribute and do the deserialization of the attributes there, not in here.
Oh yeah, the deserialization of the attributes, like the header has a different deserialization process than the
Yes,
attributes.
exactly.
That's
It
true.
will be cursed if we do it there.
Um,
So we just need to call. Okay, so fields 2. What is fields 2? It is the
the
role
row
ID.
ID.
And then we need the fields 3. Oh, sorry. The last one.
What is the last
That.
one?
But this is the inner fold, right?
Yeah, something that we
This is
can
just my
also
local
do.
notation.
Yeah, this is the inner fold. But I'm thinking actually, now that I think about it, I'm thinking about just doing instead of a fold, we now that we have the groups of like we have the table, age one, and name, we can do a map, and then we're gonna have an else here for the attributes. We're gonna assume that this if is not true. That means that your list is actually composed out of
Well,
attributes.
unless you have an attribute named table, right?
Oh yeah, oh yeah. That is assuming that we don't allow the attribute to be the name table. That's true.
Yeah, but
So,
that's fair.
okay, so what actually we need to do is, ooh, that's, oh my fucking Christ. This is so cursed, dude. Because the number of elements that we have after doing the split is not the same. We have three, three, and four
No, no, this we changed just now to be 3 as well.
to be this.
Yes.
Ah, that's that's be like runtime nightmare. But okay. So assuming that means that we have we can make the table the entity now. We can make an entity, right? So the entity is composed out of what again? It is a map. It is a table info composed out of a map of the name of the field, what position the field is, and the type. We have all of those. That's awesome. So these are these three information pieces of information. Okay, so let's make the initial entity, right? So this is going to be a map make
Dude, it is
string.
the same thing. Yes. Okay, we just picked by the positions. Okay.
Yes,
So
exactly. Then we're going to do
wait, you don't need
initial
to.
entity dot. Do I
Wait,
have an
that's not how
at?
you do the map, by the way.
That's not how we do the map. Then I forgot how to
Yeah,
do the map.
that's a module. You need to do the other thing inside the thing.
So we're
Like
doing an empty
go back.
map.
Yes, but look at the type. It's a schema dot logical map.
Schema dot logical map. Yes, that
In
makes
this
sense.
case, it is entity, right? Entity
Yes.
dot.
So it's gonna be this, and then the table info name is gonna be just
How
fields.
do I do a new line, dude? It's gonna be
Sure.
cursed.
More than it is already.
Yes, more.
and then we put fields dot parentheses. So this is gonna
Zero.
be one, no, zero.
No,
You were right,
yeah.
totally right. And then we need this thing. Let me also put
Position is one.
um, position is one. You're also correct about that. So actually, this is gonna be fields one int of string, and then the type we're gonna have to do another.
I think we have a problem, but keep going.
Yeah. So we can't do param from string, unfortunately, because this function is not doing the trick,
Yeah.
and
We
we're gonna
can
have to parse
change
that as
it.
well. I don't know
Yeah,
how we're
we
gonna
can
do that.
change it on the. Oh, we just do the. Oh, but then we have a random number inside the thing. Can we do
Oh,
something like a scanf?
can we do something like a scanf? What do
Search
you mean?
for print, like in C, like scanf, and then you put the thing, and then it picks inside the mask.
No, I don't remember that from back in the day. But
Well, we
maybe I
can
am
do
forgetting something.
easier parsing. We can do easier parsing. Go up there.
We can do easier parsing. Go up there.
Up
Oops.
on the type, serialization. Go to
Yeah.
the last one. Remove the last parentheses and put a column in the beginning.
Remove the last
This,
parentheses and
yeah,
put a column in the beginning.
no, a column.
Oh, a column.
Yeah, and remove this as well. That's it.
So what do
Then you
you want
just
to do?
split. Then you
Ah,
just do a deserialize, and then if you
nah.
see if it's a string on the first thing, you just split, and then you pick the int 32 inside.
This serialize. So this is gonna be like a candidate, which is a string, and we
That's it.
supposedly will return a t. So match candidate with. So in the case that we have an integer, we just return a t integer 32. And in the case that we have now what? Magenta?
I think you can pattern match strings as well, if I'm not mistaken.
Really?
I think so.
How the heck you do that? How to pattern match string? Oh come on.
Oh no, I think it's just head and tail because the strings they are.
That would be crazy if you can pattern match like the value of a string.
Yeah, you can only. I remember that being able to do it. Let me see. Or am I going crazy?
That's phenomenally weird.
Oh yeah, in F sharp you can,
You can pattern match the value?
and you can do active patterns to do it. Just a sec.
Oh no, but active patterns is not as crazy, but do you have active patterns in OCaml? Patterns. I want active patterns. That would be great. Implementation. Okay, there's a guide that apparently did it. While OCaml, blah blah blah. Formulation of the problem. Oh, Haskell has a bunch. Oh yeah, view patterns. That's the name. The one that I know.
Yeah, but that's too big A for what we want to do.
No, but I don't think we have a choice. Like, If we don't use
Just split
that,
the string, man. Just grug. Pick the value and split the string.
oh, so you're gonna have a
Like
catch-all.
x when do a when,
Order when
and then you do a substring.
um, string sub, then you put the order, and then 0, and then
Zero.
one,
How
two,
many
three, four,
characters?
five, six, 6. And then you compare this to
String.
string, and if this is the case,
Then you just pick
then
the.
you're just gonna do order dot.
Oh, you
Do you have
can't
a
do dot.
get?
No, there's no dot
Oh,
inside the command.
string dot.
Split, probably.
What?
Search for split.
Split?
Split on char.
Yeah, but this
Yes.
returns a string list. I want a char only.
Well, you just pick the last list, which is the second, I suppose.
You only pick the last.
Yeah, because it will we
Ah, but
split
then we're gonna
on the
have to pick
column.
the head of that, right?
We just picked. No, it's actually the last one.
Yeah, this is what I want. So you can actually
Uh,
have they have a syntax sugar for it. So
you pick
let's.
one character only on that.
Oh yeah, maybe you have
You
two
don't know
numbers
how
or
many
three numbers
numbers.
or whatever.
Yes.
Ah,
Unless you want to make your own. Just do what I said, dude. Just do a split and on char, and then you pass column, and then you just pick the last thing and convert it to string.
split on char. What is this
Pass.
expecting? A char, so we're gonna put column,
Yes.
and then we
And the
pass the
string.
order, and then you want to do what?
And then you just convert the last of this. So list dot last, I think.
Um, list list dot. Let me just check what happened here. Okay,
Até
can you
lá.
repeat that? List dot what?
Last se that exists.
Uh,
Ugh, why you come on? Man, the standard library is so bad.
uh, man, merge of seek partition. Well, we can reverse and pick the head.
Sure. Can do many other things as well.
They have reverse append, but they don't have the last.
Yeah, man. You like you have like
Init
things that you will never use, but you have like some that are.
equal cons concat compare combine append find.
Well, you know what to do, right? Oh, there's env as well.
Yeah, but then we're gonna have to use the length.
Yeah. Oh, that's bad because yeah, that's bad.
I
So
don't know
length.
which one is worse, but
Yeah, this one is not good as well.
so my question for you is: the split gonna put on the thing on the column?
By the way, this is gonna give you a list. Uh, I don't know. Good question.
Mm,
I don't think it does. It's splitting. I don't think it is adding it to anybody.
so split. So transform is a list of pairs. Oh no, it's not this. It is this. Split on char. So is the list of all possibly empty substrings of S they're delimited by the character sep. Okay. Is specified by the following variant. The list is not empty. Concatenating its element using sep as a separator returns a string equal to the input. Concatenating its elements by using sep. No string in the result contains a sep. Awesome. Okay, so this is exactly the answer. So it's gonna be int of um, int of string, and then we're gonna have to let me break this stuff. Nah. And then we're gonna do t string in which the size we're gonna have to do a fun size equals this, and then we're gonna see that this is equals to that. And then we're just gonna say that, Mageta, you there?
Mm-hmm.
And we're just gonna say that everything
Suffering
else.
here along with you.
What?
Suffering here along with you.
So unknown string
I'm kind of
to
considering FFI already, so we do less OCaml.
unknown string to serialize. So what's the problem here? The variant pattern is expected to have type T, but no constructor. What?
Oh, let x equals blah blah. It's a
Yes.
let.
So let.
Yeah, so just remove the let in this case. You're not using it.
Okay.
Victor.
There's an int. Of course, this is gonna break because we are using int32
Yes.
of int. Okay.
All right. This
After
should work, I guess.
after all this pain.
Man, I can
Oh
already
my
see like a
fucking
thousand
Christ.
things to refactor in this.
What?
I can already see 1,000 things to refactor.
And there's another problem
Mhm.
because this is returning a tuple, which is the name of the table and the row
Yeah.
ID. We can't
Hmm.
return this table info whatever because of that.
Yes. Which is what I was thinking would be our problem. The types don't match now because we're deserializing different things, right? So I know an easy way
Which
to
is
to do it. The one here,
yes.
it involves mutation.
Eh,
So we add a reference and then we just mutate the thing. Like the ACC instead, we don't pass ACC. We just mutate some variable. I mean, it's not as bad because it's still mutation on a scope. So it's not like a global state that we are doing some cursed things. But it's not
eh,
beautiful. But I don't care. Like for me, that'll be fine.
so your idea is to actually to pass a reference to this.
So line 10 up,
Hmm.
make remove ACC, then new build a new line before. Do the initial thing, or just like return value, whatever. Call it like a name. Yeah, return
Mm-hmm.
equals, and then it should be a map, an empty map, but the map is of the type the schema. So it's a schema dot. Oh wait, this is already the schema, isn't it?
Yeah, this is T.
What's the type of no, it's the other type, entity blah 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 whatever. Can you see there? No, it's not this. Go up there, man. Just scroll a little bit. Logical map. Logical map dot yes. Empty, I guess. There. And then before the ref comes before. Yes. Okay. So now you basically do instead of the tuple,
You just mutate.
yes.
Um, so it's gonna be return dot
No. Return, yes, return column equal,
column equal
no, together, like
column equal.
assignment in math, yes. And then you assign the new map, which is return with a changed value or added in this case, right? So it's like that. So it's return piped to map, not map, logical map dot add fields one,
Pipe what? Logical map
logical map dot
add.
add fields one, which is the name, I suppose, right?
Yeah, it is the
No,
name.
fields. Yeah, okay. And then the second thing is the. What's the second thing of
The
this?
second thing is the row ID.
Oh no, wait. That. Ooh. Wait, is this right? Oh no, dude. The row ID comes after. Oof. Okay. Because the what's the child of this? Oh no,
What?
we're
Sorry?
cursed. We're cursed. Because what's the child of this? Like the role ID is a tuple. Go up. You will see what I'm talking about.
No, the row ID is in the field metadata, right?
Yeah, but no, it's down. Yes, it is there. So we need to build this table. You see?
Yeah, but you can only build
So,
it after.
yeah, but we can. Okay. I know our way. Okay, that's fine. So do the following: build an empty field metadata as well. So
And okay, so this is gonna be
this doesn't need to be a this can be a local state.
initial
No,
logical
dude.
map.
Why are you doing this?
No, I'm just changing the names because return is bad. Let me change return back again, and then we can just do this. So logical map. Okay, now you can say whatever.
Okay, so uh, on the fields on Victor said he will be right back.
Mhm.
So add, and then on the second field, you're gonna make a table,
Wait, what are you talking about?
line two down,
Shoot down.
second parameter, parentheses, tuple.
Tuple of what?
Of the first thing is an empty map, which is an log. Can you go up? I don't know the type of this
I
crap.
think you're talking about entity
Entity
dot
dot
table info.
table info, yes. Dot empty column. No, sorry, comma. Row ID, which is fields two. Okay, and then you delete that, and then you convert it from a string to integer.
Oh yeah. He's still complaining
Cursed.
about logical map. This expression is type ref, but an expression is expected to have
Oh, sorry. Uh, on the logical map, do what's the name of that thing? Bang before
before of what? The here?
line four down. No, line four down. Yes. No, that's not it. Oh, sorry. Equals ref of this. I thought that's strange. Yes, no, but remove the bang. No. Remove the bang and keep that. That's strange. But you need to wrap in parentheses, right? Now the logical map and yes.
This is still wrong apparently.
Why? This expression has type a logical map int
Is
log.
logical map a pointer?
No.
No. Hmm.
Oh yes, it is. No, man. Remove the ref. Oh, I'm stupid. Remove the ref
Okay.
and add just the bang there on the logical map. That's it.
Which one?
You
This
said
one
it
or
right.
this one?
No, the one down. Because you're just using the value. Yeah, that.
Ah, now it makes sense to me now. Okay.
Okay, that's
Holy
it.
fucking Jesus. Okay, now we need to mutate this thing, right?
Now you need to. Yeah, you don't. You can just mutate on a iteration, right? So it's not as bad. The same thing.
Um,
Uh,
so in here, we're gonna do logical map, this.
mhm.
Um, actually, now that I think about it, this logical map needs to live in here. Okay.
Not necessarily, because if you loop again, you lose it.
No, we're only gonna loop throughout this group, right? This logical map only makes sense into
No,
this
we
to the
loop
scope of
through
this group.
tables as well. Otherwise, you're losing all the other tables.
I was thinking about merging them, but okay.
And you're just embrace mutation, man. You really
Just embrace. Okay, so now,
now
um,
behold the.
now we need to do a logical
Ugh,
map dot
this is going to be ugly.
update.
Yeah, like I don't see the purpose of updating because we can just add always. So what about we do?
No, what do you mean by add always? This is wrong, right? We are using the person here, but the table instead of being this table because it's gonna occur in a later iteration, this is actually having an empty. We need to mutate
Well,
this thing need to do an
Yes.
update on this, right?
So you don't need to call update. You just pick the old value and just add to the thing inside.
Yeah, but we don't know which name. Like we don't know what to do the lookup for.
Well, find, get the value, and build it again. But
No,
well,
no,
if
no,
you
no.
want to
But
use
this, no, no,
update,
no. You're not
just
getting
do
it.
it.
The problem is that because you want to do this line by line, when we are in the iteration that we are in this if, we have access to the person, right?
Yeah.
But when we are in this else, we already are in this line, which means that we don't know which table we are in. The fields one
Oh, I
in
see the
this
line is
else
gone.
is
Yeah, that's
one.
true. Yeah, the line is gone.
I think we need to merge the logical maps.
I mean, you can just do this inner and all this logic for each table, and then it makes sense. But and then that's the merge you're talking about, I think.
Yes, yes.
Man, this is much harder than just do finding a library. I did this in like 30 minutes with Microsoft stuff. Thank you, Microsoft.
Yeah, that's a rare situation in which Mageta is saying thank you to Microsoft. Okay, I propose we stop right here,
Yeah,
and
please.
then we can keep thinking about it and how to do it in an uncursed way. Usually Nathan is the one that has these sort of ideas.
There's a library called XMLM. Can you see? It looks very easy.
XMLM. XMLM.
No, all together. Yes, that.
Sample programs are located in the test directory. Examples.
Yeah, this looks much better.
Well, anyway, I think it's enough for today. It was fun because at least we could serialize the thing, and we are almost done deserializing it. It's just a matter of finding a way that doesn't suck in order to do this sort of processing.
Surprised it doesn't exist.
I would be very surprised if it doesn't exist.
I don't
Very
even know.
surprised.
I'm very displeased with the language, to be honest.
No, but the language is fine. The problem is not the
Yeah,
language. The
yeah,
problem is the
I know.
library.
The problem is the standard library. It's horrible.
So the library seems to be very bare bones, not the. It's basically it feels like the opposite of Haskell. So Haskell has multiple libraries doing the same stuff in a different ways, and this library has very is missing things that you would want to have in a library.
The fact that like a company had to do their own standard library, this already tells me a lot, man.
Well, but that's not necessarily like a novelty aspect to it. Like even in Haskell, people use different prelude. They use different preludes that doesn't
Yeah,
have
but
partial
for
functions and
example,
whatever.
think like .NET. I don't see people doing this because there's already everything there.
But you
Why would
inherit
and,
C sharp.
and
That's
more
that's
optimized?
the that's the advantage there.
No, yes, I know, but what I'm saying is like the that gives you a parameter that the thing is really good. So why would you use something else? There's no point.
Oh, maybe there is a point, but that's gonna be something very exotic, like something completely weird. Maybe you would want a third-party library, but in this particular case, I think we are missing. We should stop trusting the base library.
Yeah.
We
Yeah, the
should.
problem is, man, I don't want to blow to this with dependencies. You know how hellish it is to install the dependencies on this. And
Well,
there is no docs, man, for some of them. This is what pisses me off.
there's no
Like
what?
that J Street one that we saw. Like there was no docs for the thing. How do we use that?
Well,
The
you are
PPX.
Mageta. You should not care about docs at all.
Well, yeah. That doesn't mean we should mention the bugs, right? That doesn't.
Yeah, I'm not saying that we shouldn't care about docs. I'm saying that usually we don't. But anyway, I think we should think about how to do this better or reconsider. Not like I think that if we find a library that is doing some sort of XML or JSON serialization, Okay, it's gonna be very sad because we already did like 80% by hand.
Oh
Uh,
man, you gotta be kidding with me.
what?
Oh man, I feel dumb now.
What?
That Jane Street thing, you literally just add deriving XML and then it just spits the thing for you.
No. But this already. Today was a draft session. We did these like with the spatula as well, in which we explored doing a feature, and then usually nothing comes up with a better solution. This time you were the one that found the better solution. Awesome.
Yeah, but I thought it would be hard. It is not. It is easy. Very
Yeah,
easy.
usually this is also the case. But anyway, that's part of the drafting it. We we
I'll
we
just put the command here. Look, it's just this, and then you just add this.
okay. I'm gonna finish the recording now. So stop.